Okay guys, the question is the smooth can C is lifted from point A to point B by a rotating rod. The mass of the can is 3 kilograms. So this is the mass of the can, which is 3 kilograms. Kilogram is the mass. Neglect the effect of friction in the calculation of the size of the can, and R is given. The expression of R is given. Forces of the rod on the can. So you have to find out the forces of the rod on the can. So let me show you the forces. So if you, this is my radial vector, agreed? This is radial unit vector, and perpendicular to the radial unit vector is the transversal unit vector. One force is pushing this along the transversal direction, which is the applied force, and another force is, like if I draw a normal tangential coordinates with a different color to show you that, this is the radial unit vector, this is the normal unit vector. So this is the normal force, because there is a support as well from the path which is supporting this can. Okay, this is the tangent unit vector and this is the normal unit vector. So what is this? If this is tangent, what is this psi angle? So you have studied that psi equals to tangent inverse r over dr over d theta. Now what is r? R is 1.2 cosine theta, and what is dr over d theta, which is negative 1.2 sine theta. Agreed? So this is my I should say this is tangent psi. So now if you do the math at 30 degree, so if I show you, let's write down in my computer here. I can write down here tangent inverse of 1 over tangent 30, 60 degree. You got my point? So tangent inverse of cotangent 30. This is cotangent. Okay, negative sign means this is clockwise from the radial unit vector. You see my point? From the radial unit vector you have to move clockwise. Agreed? And what is psi now? 60 degree. So if it is 60 degree here, so what is this angle? Because radial and transversal, they are 90 degrees, so this is 30 degree. And what is this angle? Sorry, this angle, this is 30 degree. And what is this angle? This is 60 degree. If this is 60 degree, this is 30 degree, because tangential and normal, they are perpendicular to each other. You agree my point? So let me show you closely here. Let me explain it to you again. So this angle is 30 degree, and vertical angles, they are 30 degree, and this transversal and radial is 90 degree, which is, so you're left with 90 minus 30, this is 60 degree, and this angle tangential and normal is 90 degree, so you left 90 minus 60 is 30 degree. Have you understood? So we were looking for the forces and their angles with the radial and transversal coordinates. So we are able to find out those angles. So let's do the math. Remaining math is easy. So let me grab one more slide here to show you. So as we already have calculated this angle with the radial, look, angle with the radial and normal force, which is 30 degree. So this is 30 degree, and I have explained it in my earlier explanation. So this angle is also 30 degree. How? Look, this angle, I did not draw the weight, but the weight of this can is acting downward. So this angle is also 30 degree. How is it 30? Let me show you. It's very messy here. Let me show you again over here. Take this diagram again and show you over here. How is it? Okay, this thing is clear that this angle is 90 degree, this 30 degree, 60 degree. And radial is, this is let me show you, this is transversal, perpendicular to the, this is transversal. So if this is 60 degree, this is 60 degree, if this is 60 degree, vertical angles. And what is this out of 60? Because this is radial unit vector, this is transversal unit vector. Agreed? So this is the same thing telling us in the slides. Do you understand that point? So now we have found angles with, because the main objective is find the angle of the forces along the radial and along the transversal unit vector. So let me grab it here and put it over here. So we are able to do that, and then the rest of the things are easy. You apply the Newton's second law here for the radial and transversal unit vector, as you can see. So let me show you over here. This is the this is n sine 30. So let me reduce the size here. What is n cosine 30 is along the radial. So you see n cosine 30 is the force component of the normal force along the radial. This is along the radial. And W, look, this is W. And this is negative W sine 30. You see my point? This is along the radial, but opposite direction. Negative sign is due to the left hand side direction. You understood these two forces? So how about the transversal? In the transversal, F is along the transversal, so you don't need to resolve F because it is already along the transversal unit vector. The remaining two forces, you can see this is downward, so it is negative W cosine 30, and this is upward, this is positive. So this is positive sine 30, and then you are left with finding these forces. AR and A theta you have already calculated. Let me show you that slide here. So this I have explained in the previous question, so it is not difficult. You can just follow step-by-step method. We have been doing this many times. So acceleration, radial and transversal, you already found from this slide, from this formula, and then you apply Newton's second law to find out the unknown forces. This is the answer